All right, let's keep on keeping on. Now, this section is a biggie, is a great big one. So the natural logarithm and natural exponential functions, we are going to use these for the rest of your mathematics and probably physics career. These are super big, all right? So write this stuff down, learn it, love it. We've got this, all right? So the first thing we're going to look at is the definition of the natural log. The natural log. Okay, so the natural log of a number where x is greater than 0 is the natural log of x equals the integral of 1 to the x of 1 over t dt. All right, so we're going to start off here with our basic definition here of a natural log. Now hang on to this. I'm just going to put it down right now, and then we're going to make our connections associated with it. All right? Okay. So, but before we jump into that too much here, let's look at the properties of the natural log. And these are, yes, we're going to talk about this just because we happen to be talking about the natural log, but these are just logarithmic properties in general. You don't have to have ln, right? Because we know ln x is natural log of x, right? So it doesn't have to be the natural log. These are just properties of any logarithm. Okay, just wanted to make that clear. Domain is from 0 to infinity, and the range is infinite. Now, what I also like to look at on here is we have our graph, right? Our graph here of the natural log. Let's change our color so you can see it. Goes up like this. And I have an asymptote on that y-axis. That's good to know. It's always good to know the basics of graphs, right? And so here's the basic of our natural log, or any logarithmic for that point. This crosses at 1, because it always does. And so then I have that asymptote, and that's why I'm going from 0 to infinity, but 0 is not included because there's an asymptote there, so that's why it's a parenthesis. All right, there's our domain and range. I also know that if I take the natural log of x times y, like that x times y is my inside function, we can split those apart, and this is equivalent to the natural log of x plus the natural log of y. Logarithmic properties, right? Something you already know. These is just review, making sure that we've got these down. If I'm dividing x divided by y and we split those up, what operation are you doing? Yeah, subtraction, right? Natural log of x minus that natural log of y. All right? If I have the natural log of x to the p, right? So the natural log of x to the p, you can take that exponent and bring it in front to get p natural logs of x. That's the power property. We've got product, quotient, and power. Those are our 3 properties that we're looking at. All right, this is all algebra review. Up to this point has all been algebra review. Now, ladies and gentlemen, we're getting into a little bit of calculus here. Number 5. The derivative with respect to x of natural log, and these are absolute values of x, is 1 over x. Oh. Look at what's happening up here, and this is where we're making a connection. Think back to Calc 1 and the fundamental theorem of calculus. The fundamental theorem of calculus has 2 parts, right? It's the part where you can find a derivative based on an integral where you have that variable and you plug that in and you get 1 over x. That's the derivative, right? Fundamental theorem of calculus part 1. Then the fundamental theorem of calculus part 2 is the one that we do more often, right? Where you have that definite integral and you plug things in. But the fundamental theorem of calculus part 1 hits this bill right here. All right? And we can also integrate. If the derivative is 1 over x, if I want to integrate 1 over x dx, because you have to have that differential, that's going to equal the natural log, and you have to have your absolute values. And it's indefinite, so we put a plus c. No these. They're going to be so common that it's basically going to be like breathing. Oh, the derivative of natural log of x? Oh, 1 over x. Oh, the antiderivative here of 1 over x? Oh, natural log of x. It's going to be like breathing. They're so common. You have to know those because, do I ever give you any formula sheets? That's right. Negatory, good buddy. Nope, so you have to know it. And these, know them and love them. Okay, I'm going to try to squeeze in a couple of examples here because I want to have these rules up there so we can reference them. So here's example 1. We're going to find the derivative. Here's part A. Y is equal to the natural log of 4x. So the chain rule is valid no matter what you do, right? So if I take y prime here, this is going to be 1 over the inside function because the natural log here is 1 over x, which is the inside function. So I take this inside function, and then the chain rule tells me I have to multiply by the derivative of the inside. So the 4's cancel, and my derivative here is 1 over x. All right? Okay, try this one on. I'm not going to do all of these. I'm just going to pick a couple here. Y is equal to the natural log of the absolute value here of secant x. I'm going to make these thick so you understand their natural absolute values. Yep, same thing. 1 over the guts. Y prime is equal to 1 over secant x. And then the chain rule tells me times the derivative of the inside. Newsflash, I expect you to know the derivatives and of all of the trig functions, right? The derivatives of all the trig functions. So here I have it secant times the derivative of the inside. The derivative of secant is what? Secant tangent, good. If you don't know that, learn it. Because that is something that I do expect you to be able to just do by looking at it. Oops. Y prime is now just tangent x. You can't always cancel something out. If you can't, then don't, obviously. But if you can cancel and simplify that rational expression, then you should. Okay. Now, I am going to go ahead and do this 1b because it's a good one. But I didn't really have much room, so let's try it here. Here's example 1b. Find the derivative. Y is equal to x natural log of x. Okay, tell me things you see. Yep, I've got x times the natural log of x. So what rule do we get to use? Product rule, yeah. So I'm going to be doing the product rule. So these are nice because we're getting a nice good recap of derivative rules with from Calc 1. Getting it all fresh in your brain. So the derivative of the first term is 1 times that natural log of x, because it's times the second, plus the first times the derivative of the second. The x's cancel, because this is the same thing as x over 1, right? And now I'm left with y prime is equal to the natural log of x plus 1. There it is. All right. Okay. You can write y prime over here. You can write dy dx over here. I don't care. I just wrote y prime just 'cause it's what I've got. Okay, let's try this one. Here's one from your assignment. 7.2.13, find the derivative. Sometimes it's not given to you on a silver platter like the problems we've been given so far. Sometimes you get the opportunity to do a little bit of work first. What if I have something like this up front? Yeah, you can. I mean, you can do the right up front. So I'm sure several of you are doing this, and I say I'm going with it because I've heard it so many times before. Y prime is equal to 1 over x plus 1 over x minus 1, and then you take this and do the quotient rule. Quotient rule. That is unpleasant. Instead of doing that, the better way to solve this problem is to keep the y, right? We're not doing the derivative yet. We're going to do some algebra first. Use your logarithmic properties to break this down. So the natural log of x plus 1 minus the natural log of x minus 1, and that's why we went over those. Right? Now you can look at this and be like, oh, okay, that's super easy. Yes, it is. Notation is a huge deal. I don't know how to impress that as big as it is. It's a huge deal in math. So notice this is a y. This is a y prime. If you put y prime here, I'm going to count it wrong because it's not the derivative yet. You need to make sure you're using the appropriate notation. So the natural log here is going to be 1 over x plus 1. Well, the derivative of x plus 1 is just 1, so we're good there. Minus 1 over x minus 1, and we're in the same boat there, so we're good. Now, anytime you have something super easy like this, if it is an easy rational expression, then simplify. If it were something like super crazy, you can't get a nice easy common denominator out of that, then don't. But here, right, we've got a nice easy, I'm going to take this times x plus 1 over x plus 1. Take this times x minus 1 over x minus 1. I'll go back to red. Scoot it up a little bit here. So I have x minus 1 minus x plus 1 over that common denominator. And you can distribute the negative there. So that has a plus x and a minus x that cancels. And I have negative 1 and negative 1. So y prime is negative 2 over. If you want to leave it as x plus 1, x minus 1, you can. If you want to change it to x squared minus 1, you can. I don't care. That is your choice. All right? But you do need to simplify that, and then that's what makes it easier. All right? Okay, so if you can use those logarithmic properties, you should do those first and then work it out. Okay, derivatives. Nice.